Perfect. So thank you everyone for joining us today. Today we are going to be having the second and final session of our AWS 2019 recap. Just again, what these sessions are about. We're going past, or we're going through the features and services that were introduced in the last AWS reInvent 2019 in Las Vegas, December of last year. This is the first recap that we're doing, so we want to use this as an opportunity to engage our community, and as the first one, we are going to be monitoring the engagement, and we'll be using this to determine how we are going to be doing more recap sessions in the future. This is just our way of coming together and talking about the new features, the new services that AWS has introduced in their reInvent. A quick announcement, I don't know for anybody that noticed, but the reInvent this year is actually going to be free and virtual. So, just make sure to check that out. I think now we can all attend. So let's jump right in. A brief introduction about the community. This is the AWS Nigeria user group community. We are a community of Nigerian professionals that are involved in the AWS and the cloud computing space in general. But this particular group, what our goals or what we are trying to focus on is just to promote the adoption of cloud technology in Nigeria and in Africa, and also to build networks amongst ourselves, to share ideas, and to disseminate knowledge about AWS and cloud technology in general. So we hope that this group is going to benefit everybody, and we are always welcoming new ideas and new ways of benefiting our members. So please feel free to always communicate your ideas and opinions. Today's session is going to be divided into two parts. We're going to be talking about, well, first of all, let me talk about the presenters. We have Adeshola, who is going to be presenting. He's going to be presenting Amazon SageMakers Studio. Adeshola is a machine learning engineer at Terragon Group. He's also an electronics engineer who got his engineering degree from the University of Lagos. He specializes in Python, computer vision, feature engineering, and predictive modeling. So thank you, Adeshola, for accepting to present and talk to us about Amazon's SageMakers Studio. We hope to learn a lot from you today. We also have Adekunle. Mr. Adekunle Lawal is an experienced cloud architect. He's also a polymath, so he knows a lot of stuff. And he has about 12 years of experience working with Linux and cloud computing in general. He has helped deploy cloud computing infrastructure for leading firms in Nigeria like FIRS, Huawei, Owando, DPR, and so on and so forth. So he's definitely an embodiment of cloud knowledge here, and he's also a Real Madrid fan. So for those of us that are Barcelona fans, feel free to reach out and throw shit to him after the session. Adekunle is going to be talking to us about Amazon Fraud Detector. Amazon Fraud Detector is actually very new. They did introduce it in the last reInvent, but they did not release it into the public. So this week we had to try to get some movement around to see if we can get it approved for this session, and it actually got released publicly this week. So it's almost as if we got lucky, but that's great news for us. So this is one of the first people to actually use fraud detector in public light. So it's a great opportunity for us to learn. Thank you again, Adekunle, for helping us and showing us this service. So just a brief, intro or summary of what this session is going to be looking like. We're going to have Shola present SageMaker Studio for about 35 to 40 minutes. And then immediately after that, we'll have Adekunle talk about fraud detector for about 35 to 40 minutes as well. And after that, we'll have Q&A. So if you have any questions from any of the sessions, please feel free to send it into the chat, or save your questions until the end of the sessions, and we're going to open the floor, and you can unmute your mic and ask your questions. Any questions are allowed. It could be related to this session, it could be related to the last session, or just the community and the group in general. We will be releasing the video recordings of these sessions into the WhatsApp group and to the Meetup group. The video will be posted on YouTube So that's definitely going to happen. I know that's a question we get a lot. And then there's going to be announcements at the end. We'll just talk about like a few things that we just want to announce to the group after the sessions. So the first session is going to be Amazon SageMaker Studio. So I will let Shola introduce himself. Shola, over to you. Please feel free to share your screen. If you're ready to share your screen, let me know. I will stop sharing my screen and you can take over.
Okay, yeah, we should do that. Let me just share.
All right, perfect.
Yeah. So I'm unable to share. I'm getting a host disabled attendee screen sharing. Do you want to check that from your end?
Yeah, sure. 1 second. Can you try again? I can see here that it says multiple participants can share.
Yeah. Can you see my screen?
Yes, I can.
Okay, so yeah, let me just start. Good evening, guys. My name is Adeshola Afolabi. So I'll be taking us through the SageMaker Studio. So basically go through a couple of things, starting from the AI and ML stack. I'll take us back to SageMaker, some limitations of the SageMaker, and we'll go into the studio proper and a small demo on the studio. But before I dive in, let me just introduce myself once more. So I'm Adeshola Afolabi. I work for Terragon Group as a machine learning engineer. Terragon is a data marketing company. So what we basically do is to help brands reach the right end users for some of their product and offerings. So that's what I do at Terragon. So let me dive right in. So starting with the ML and AI stack. So basically it's basically subdivided into three. There's the frameworks and the hardware, there's the platform services and the application services. And if you notice, they are sitting on top of each other. So you need the application to sit on the platform, and you also need some frameworks. So some of the frameworks that you basically find in your machine learning environment are things around TensorFlow, PyTorch, and for those of us that like to do deep learning, so these frameworks are supported. Next is the platform services, which is where we have the almighty SageMaker that allows you do your training, modeling, deploying, and the likes. And lastly is the application services, where we have some product and services such as vision, speech, language. I know some of us might be familiar with Amazon recognition. Yeah, so stuff like that we have on the application layer. So let me start with the SageMaker. So Amazon SageMaker is, think of it as independent components that allows you build, train, and deploy. On the SageMaker, we have in-house algorithms, and you also have the opportunity to bring your algorithms. And of course, like I mentioned earlier on, there's support for the frameworks. So before I move forward, I'll be switching between tabs just for us to have some visual context into what I'm saying. Yeah, so these are the this is what it looks like when you go on AWS, you check SageMaker, you see stuff like this. You have ground truths, notebook, processing, training, and the likes, and there's also the marketplace. So typically, if you want to do any building or whatnot, you basically come to the notebook. It gives you access to a Jupyter lab, where you can do your stuff. Sorry, I'm trying to move this. Okay. Yeah, so this is an example of what a notebook looks like. Basically where you can build and deploy, train, and everything you want to do. Your machine learning workflow end-to-end can be done on the Jupyter Notebook. So I would approach this from a storytelling perspective. So let me tell you about my very first encounter with the SageMaker. I remember I was just learning then, and I started off with the AutoML. So what the AutoML allows you to do is you put in your data sets and you basically have like your code and pre-written for you. And all you have to do is enter the code, and at the end of the day, you typically get an endpoint, or depending on what you want to achieve, it could be just to have your model artifact or whatnot. So that was the way I started. I started with the AutoML. And out of curiosity, I wanted to know what was happening under the hood. So I started exploring with other services as well, extended to services like S3, trying to see if I can read my data directly from S3. What I did initially was to upload to the Jupyter environments, train and play around. But I extended it to working with S3, eventually moving whatever outputs from S3 to Athena. So I get to also integrate the output of my models to Athena. So that was the flow for me back then. And of course, because of curiosity again, I went for that to look at other things. So SageMaker allows you to bring your model with the help of Docker containers. So you have like a deep learning model on your local machine and you want to replicate the same thing. You can basically package it with the help of Docker and take it to the environment. So I have something here that shows like an example of how it is done. By the way, they have like a very good documentation on how you can package your stuff and bring it to SageMaker. So this is like a flow of how it works. So you have like your parts. Because you're using Docker, you might not really have access to the EC2 or whatever that hosts some of your packages. So you need to follow this convention and you build. And of course, to the right, to the left here, you have your Docker container, you have your requirements, you have your notebook. And if you go through this documentation, there's like a step-by-step into how you can package your own model. It could be a scikit-learn model, it could be a deep learning model, and you're able to bring your own model into SageMaker. So I was able to do that. And the end goal is either to have like an endpoint, or you want to have like a batch transform job where you can score periodically. And next is I started exploring Studio. So taking me back to the way I started with SageMaker. So one of the very first things I did with Studio was the use of Autopilot, which I will be sharing as we move forward. So next up is, so there are some limitations with SageMaker. There's a lot of moving parts, and you basically have to, move from. So take for example, this is a list of things you can do on the SageMaker. You have the ground truths, your processing, your training, your inference, and when you come to your notebook, you build. There's a need to view an endpoint. You come here, you come to your training jobs. There are a lot of moving parts. So you're not able to easily track, and there's something called experiments, meaning you have different variants of what you've done. So you're not able to track and see what you have with your model or training or whatnot. So that's where the experiments come in. So you don't have that with the normal SageMaker. You're not easily able to compare as well. When you have like a couple of models, maybe use the same data sets to build something scikit-learn related, you build a deep learning model and whatnot, then the ability to compare, let's say your evaluation metric is, you're using accuracy and all that, is very, very difficult to compare. Next thing is, with the SageMaker, you find it difficult as well to monitor the quality of your model and also to detect drifts. I'll talk more about drift detection. So basically, it could be that the training data you used from inception changed, something happened. People that used to live in Lagos, they are now in Abuja, they don't live in Lagos anymore. So what do you do about that? Is it going to affect, take for example, marketing decisions and whatnot? So that's another limitation. And lastly, the ability to scale fast, moving from experimentation to production quickly. So you don't basically get that on SageMaker. And that's what the studio has come to fix. So the SageMaker Studio is an integrated development environment that helps you build, train, debug models into production. And so I'll do a side-by-side of SageMaker and SageMaker Studio so we can note some of the differences. And before I go in there, there are a couple of things that we have in the studio that are not in SageMaker. So number one is the experiments, like I mentioned earlier on. So we have the introduction of experiments. We also have Debugger, model monitor. Of course, notebooks were in SageMaker, and there's also notebook in the studio. And Autopilot being the last thing. So this is SageMaker. If you look to the extreme left here, you'll see a couple of items. This is like your sessions, your repository, Gits, some settings and whatnot. So these are everything you would see on SageMaker. However, if you come to the studio, one key thing to note here is you'll see this funnel-like image. So this is the experiment I was talking about that is introduced in the studio. So you have this. Another clear differentiator is also to the right of your environments. You also have a share button, which I will get to. So this basically allows you to share like whatever work you've done, your Jupyter notebooks and dependencies, and the list goes on. So those are like major differences. And of course, just the background colors and very, very minor things. So those are like the major differences with SageMaker and SageMaker Studio. So starting with the notebooks. So the difference with SageMaker and SageMaker Notebook is Studio. For the Studio is you're able to, for me, the major thing I noted was the ability to share. So with your SageMaker, if you look at what I have here, there's no share button, so I can do all the work and maybe I have to push to Bitbucket or something for someone else to be able to have access to what I've done. But with the SageMaker Studio, you have the option here. So you can, if you have a team of 10 people, they can easily share their notebooks and they can get to collaborate and work together. Another thing that is worth noting here is you are able to switch your compute easily. So for those of us that do deep learning, we like to use GPUs, right? With SageMaker, if there's a need to switch from your CPU to your GPU, you have to stop the instance, you start again, and it's not very easy. But with the studio, you can switch on the fly. You can just basically come here, you just switch from CPU to GPU. It happens very, very fast. And by sharing your notebook as well, you're not just sharing the code, you're also able to share the dependencies, the libraries, and you also have like permissions, the IAM rules, people, if you want full access, if you want people to just maybe work with S3 and SageMaker and stuff like that. So those are some of the improvements with the SageMaker notebooks. Next is the experiments. So for me, this is like the holy grail. I like the fact that on the particular screen, I can basically see everything going on. So the experiment allows you to have multiple variants of what you're doing. You're able to visualize, you're able to compare. Take for example, you have 5 models that you've built. logistic regression, use PyTorch, TensorFlow, and you want to see the performance. Take, for example, you have accuracy as your metric. You want to see which would give the better outputs. So with the experiments, you can easily see everything from just a single screen, as opposed to switching between tabs that we used to have in SageMaker. Okay. Next is the debugger. So this is another interesting thing that they came up with. So with the debugger, you're able to make adjustments on the fly. I'll give an example. Say you have a neural network, and let's say you have like 10 hidden nodes or layers. So if that's not optimal for what you want to achieve, you can easily change it either to increase it or reduce it. And take, for example, you're tracking error of each of the layers. You see that it's not improving, or the model has converged at maybe the 20th epoch or whatever. So at that point, you need to stop training. So what the debugger helps you do is you're able to make adjustments to whatever you're doing, and you can basically just stop at any point, or you change anything at any point. And of course, there's also the framework supports for TensorFlow, PyTorch, MXNet, and you can get all these things real time. There's visualization, there's also the CloudWatch supports that you can use. The next is the model monitor. So I spoke about drift the other time. So what happens with the model monitor is, if, for example, you have a model that is deployed and some weeks later, things change, or months, it could even be years, things change, your users are no longer the same, performance is dropping, you need to track back or know what is happening. You can check if there's a drift in your model, or even if there's a drift in your data sets. So all these things are done for you automatically. And it helps you just optimize what you have in production. And lastly is the Autopilot, which is what I'll be showing us in a bit. So the Autopilot is a data to prediction functionality. So you basically have to just provide the data set, and everything is taken care of for you by SageMaker Studio. So all you have to do is specify an S3 parts, your machine learning workflow, preprocessing, feature engineering, training, tuning, and the likes. They're all done automatically for you. So there are 4 stages of the Autopilot. There's the part where the Autopilot helps you analyze your data. There's feature engineering, there's model tuning, and at the end of it all, you get a list of candidates with their metric, and that's when you get to pick what would work for you best. So that's the Autopilot. So I have something here on the Autopilot that I would like to show us. So basically, like I said, all you have to do is just specify any S3 parts, and the rest is being taken care of. So I have a file part here that has these data sets, age of users, what they spend, their location, things around the kind of gadget they use. And the target variable here is this event. So it's binary, 0 or 1. So this is what you want to predict at the end of the day. The way machine learning works is you have your train and your test data sets. And of course, from the name train, you use your train data to train a model, and you use your test to validate the performance of the model. So at the end of the day, what you want to achieve is you want to have a 0 or 1 for your test data sets based on whatever model you've built. So coming to the, or using the Autopilot, all you have to do is come to the experiments, you create new experiments, you specify the experiment's name. There was something I did for this particular session recap. You can name it anything you want. You put any S3 buckets here where your data is stored. note, the S3 bucket should be in the same region as your SageMaker Studio. If it's in a different region, it's not going to work. So you specify other things like the attributes name, that's your predictor. Remember, there's a predictor here, which is the event. So you specify it. Take, for example, yours is Y, or it could be costs, it could be whatever it is, depending on what you want to achieve. You put it here. You also put the S3 parts where you want your output to be written to. It could be that you want your model artifacts, you want stuff to be written to a particular S3 bucket. So you specify the parts here. You also specify the type of machine learning program and problem. So it's fine if you leave it as auto. SageMaker detects what you want to achieve automatically for you. Or if you want to be more specific, you can tell you can tell SageMaker if it's a binary classification problem, a regression program, or whatever. But if you leave this as auto and you create experiments, then everything starts. I'm not going to do that here because the last training job I did took about 9 hours. So it just shows the output of what I did, not starting all over again. And of course, we don't really have that much time. So when you do this, you get to progress from stage to stage. So you move from analyzing data to feature engineering to model tuning, and at the end of it all, you have completed. So the good thing about the studio is for each of the process, what happens is everything is tracked for you. And it's as good as you even get a notebook at the end of everything you do. So you get a notebook for preprocessing, you get a notebook for training, and even in terms of infrastructure and other things that were used. So for the dataset I provided, remember the target variable is events. You're seeing events here. It has 13 columns. It's binary 0 or 1. I have this number of rows. So this is a notebook I got that was created for me automatically. I didn't have to lift a finger. All I did was create. I clicked on the create experiments, and all these things were handled. So you also it helps you explore your data. Basically see what you have. Do you have missing values? Do you have outliers and stuff like that? So if you go through the data preprocessing notebook, you'll find a lot of these things that we typically do on a normal day. As data scientists, you find everything here that is being done for you automatically. Next is after the data analysis, feature engineering happens, and this is where it gets interesting. So there are like a lot of variants that are being considered at this point. When the autopilot helps you combine several things. Feature engineering, preprocessing, it could be that for you to fill NaN value, you want to use a simple imputer using column transformers. You want to do one-hot encoding, and the list goes on. So what happens is everything is separated as candidates. So you have several candidates, and each of these candidates will be a combination of different things. So the first candidate could be simple imputer plus one-hot encoding plus standard scalar. Another candidate could be principal component analysis plus standard scalar plus one-hot encoding. So there are a lot of variants that are considered here. And the end goal is so that by the time you build or by the time you want to train a model, let's say you want to have a logistic regression model. So the logistic regression model will try each of these variants to see what would perform best. So everything is tracked for you. So if you come down here, recap, okay, yeah. So I have a list of training and tuning jobs that happened while this autopilot took care of everything for me. So you can see what's all was being done. So this is an example. If I go into one of this, okay. Okay, yeah, so if I go into one of these, you see stuff like this. You see AWS training job, you see transform job, you can click on it. For the same candidates, you see another training job, you see a preprocessing job. And when you click, you can see things like the metrics. You can, so this is saying the error is 0.006, 0.00633, and it goes on. You can see the artifacts, the S3 parts where the artifact is written to, the debugger I mentioned earlier on, even though it wasn't used here. And it just goes on and on. And you can also see your charts and do some manipulations. So you can, if you want to view the error, for example, this is your train error chart. So you can see the same metric here, train error 0.006 is what we have here. So you can basically see the error per candidates. You can compare candidates. You can pick 2, 3 of these and see which of them would have the least error. Also the preprocessing job, and at the end of it, what you want to achieve is you want to pick the best candidates. And when you pick the best candidates, what you do is you deploy. And deploying could mean that you want to have an endpoint where you can send requests to an API, or you want to have a batch transform job where you can always consume the endpoints to score your users. You can put it back to S3, put it on Athena so you can see what is happening. And yeah, so basically that's what to do. Yeah, so this brings me to the end of the Sagemakers Studio. I'm sure we'll have questions, and I'm happy to answer the questions. Yeah, thank you.
Yep, thank you very much for that, Shola. That was a very thorough and deep session. I'm sure we have questions. I have questions, so in the Q&A session, we'll definitely come back to that. Thank you very much for that. Do you mind to stop sharing your screen, and then we can go on to the next session? The next session is going to be Amazon Fraud Detector, and Adekunle is going to be showing us and talking to us about Amazon Fraud Detector. Adekunle, please share your screen.
Hey, Sam. Hi. Okay. Nice session by Adeshola. Really nice.
Yes.
Also learned a lot from that. Okay, so I'm sharing my screen now. Okay, let me know when you get to see it.
I can see your screen.
Okay, cool. Okay, just a second, please. Okay. Okay, my name is Adekunle Lawal. I'm an independent cloud contractor. So basically, I work with companies to move them into AWS. And at the same time, I'm a partner with Opal Labs, where we are trying to revolutionize skincare by using AI. Thank you for the opportunity to give this talk. It was quite short notice because the Amazon Fraud Detector just came into general availability like some days ago. So I did my best to actually put something together that would make sense and give us deep insights into what the service is all about. Okay. So basically, Amazon Fraud Detector is a fully managed service that makes it easy to identify potentially fraudulent online activities, such as online payment fraud and the creation of fake accounts. So basically, it's just a service that AWS offers that allows you to do fraud prevention and also be able to anticipate ahead of time transactions that will be fraudulent and those that would be legitimate. Okay. So AWS has been in the business of fraud protection since almost 2 decades now, and we all know it's general knowledge that AWS runs the largest e-commerce store in the world, and at the same time they have the largest public cloud infrastructure. So it's you can imagine the scale at which the kind of fraud prevention mechanisms they would need to deploy to actually deter people from actually taking advantage of their systems and causing losses. So the kinds of fraud that AWS or Amazon as a company is used to battling is we have things like stolen credit cards. So people steal credit cards and now use that to buy services or probably buy maybe a TV on Amazon.com or maybe buy some other kind of maybe a phone or something. And you know that's once that card is flagged, they have to, depending on the country where that is done, you probably have to recompense the owner of that card. At the same time, there are prepaid intentional non-payments, which is when someone makes use of your service. Now, AWS is such that you have to pay at the end of the month. So I could actually use, I could make use of, let's say $500 or $1,000 worth of service. I could be indebted to them to that amount. And at the end of the day, I just elope and they have to sort that out themselves. So over time, they've had to work on getting this resolved and getting to discover how to fix all this. At the same time, we have account takeover, which is when someone takes over an account. Say, for instance, your online banking account is taken over by a bad actor, and they start doing transactions that were not authorized. Also, we have the likes of the recent hack in Twitter, where accounts were taken over, and the likes of Barack Obama's Twitter account was used for Bitcoin scams. So also we have API key misuse. So someone sees your API key on GitHub and takes over your account or starts running resources. I've had people whose accounts, AWS accounts, somebody just started, they created servers and started running services on those accounts. So you see things like that happen. At the same time, we have abuse. So free tier is, AWS runs a free tier, which is, they allow you to use the service, some limited sets of services for about 12 months. So you don't need to pay for that. So you can have someone that now creates like 7 accounts. So he's running 7 free tier accounts and using all the services, and that is going to be costing AWS because those services should actually be used by other people. So they need to actually fix that. Okay. So as a based on that, customers have been complaining to AWS that the customers also had the same issues, and AWS saw it as needful to now create a service that would enable customers to be able to prevent all that. So here on this slide, we have some common fraud, common types of fraud that we get to see online. So we have promotion abuse, which is when somebody, you have a coupon. Let's say, for instance, we are giving coupons for domain names as a hosting service, and somebody is making use of the coupons to register a lot of domains. So that's a loss on the side of the company. We also have affiliate fraud, and we have reshipping fraud. I normally get emails in my email box where people tell me, okay, do you want a job where you can package like packages, you can repackage packages and now send it to certain addresses. So, people buy stuff with stolen credit cards. Then they now look for people to actually help them repackage it, send it to different addresses before they now send it to the final address. So those kind of fraud, reshipping fraud is quite common in Nigeria too. Then account takeover and identity theft, then friendly fraud. So this is a diagram showing like a chart, basically from it's from the federal FTC in the US. So it shows us the trajectory of credit card fraud reports. So between 2014 and 2019, we can see that the trajectory is actually going very high and it's quite steep. So you can just imagine, because of the coronavirus work from home, a lot of us have to now go online to work from home. So you can only imagine what 2020 will be like, because there's so much activity online now compared to previous years. So credit card fraud is something, even in Nigeria, it's something that is on an upward trajectory, and companies need to fix it. Otherwise, they'll get to lose the lot. So here we have, I couldn't get so much data about Nigeria, but I got some from the CBN and also from the IJCTT. So here we have, so basically here we can see that in Nigeria now, this is for 2016. So we have internet banking. So basically you find that the actual loss when it comes to internet banking is 320 million naira. That was as far back then as 2016. So you can imagine what the losses will be like now. We also have e-commerce losses at 132 million naira. And mobile and POS in the range of 200 million upwards. So there's a lot of fraud going on in Nigeria, and the banks in Nigeria and other entities need solutions to actually get this sorted out. You can see ATM fraud is actually the highest, and followed by mobile and POS fraud. So there's actually a lot of fraud going on within our environment, and it's something we see in the news every day. So I'm sure we know about this. So fraud detection actually is very difficult to actually get done. The reason, one of the reasons is because the bad actors, those guys, the fraudsters, they are very dynamic. So they tend to change the methods every now and then. So they don't stay on the same method for too long. And businesses also need to be dynamic so that you can actually stop the threats and be able to mitigate the losses. The losses which also amounts to billions of naira. I just showed us the ones in Nigeria. I'm sure right now probably they'll probably be going into the billions of naira. And likewise, it's all over the world. So many companies are actually getting to lose money. And the sad thing about it is that for every $1 that a fraudster, a company pays to a fraudster, they need to pay back about $3 back to the people that were like the people that were at that were taken advantage of. So online businesses also they are very prone to fraud attacks because of the nature of online businesses. So once you start an online business, you are open to the world. A guy in North Korea can just decide to hack into your systems and steal your money and stuff like that. So it's actually, online business is very risky. And also it's in the traditional sense of fraud detection, you normally need to have a fraud detection team. So, and it takes a lot to actually, you need to employ this fraud detection team. You need to train them. So it's a lot of money to actually get humans to do fraud detection. So a lot of companies actually spend so much doing that because if you are not using machine learning, which is what AWS fraud detector is based on, then you are going to have to do a lot of things manually. And it's going to cost a lot of time and a lot of human effort. And at the same time, it's dependent on others to update detection logic. So what this means is that if for instance, the bad actors have changed, let's say they start using a new method, which we've not already planned for. If you are not using DevOps, so most likely your code base doesn't change that fast. So you'll probably be like 2 weeks, 1 month, or even several months behind because you need to update your code to reflect the current realities of what these bad actors are actually doing. Here we have a breakdown of the method of contact and the amount lost to fraud. So basically, this is just to give us an insight into the kind of amounts we're actually talking about. So we have 42 billion, this is in dollars. So $42 billion is lost via phone fraud. So different types of phone-related fraud. Email fraud, about $173 million dollars, I'm saying billion, sorry. $1 million is lost to that. And websites via online is actually 227 million. Okay. So some facts about fraud detector. Fraud detector, like we're doing a recap of reInvent 2019. So fraud detector was actually released at reInvent 2019, but it came into general availability, meaning that everyone now can now use it. Like they came in on the 29th, if I'm correct, of last month, which is just some days ago. It's actually based on lessons from Amazon's history of fraud prevention, which I've actually explained earlier. So Amazon saw it needful because they had a lot of customers complaining that they're experiencing fraud, and is there something that Amazon could do about it? And they thought it wise to actually create this service. The model supports up to 100 inputs to train a model. So basically, you need just two inputs to actually train a model. So it could be your email address and the user email address and the phone number, user IP, just two data inputs are required to actually train a model. But you could actually go as high as 100. So meaning that maybe the bank bank information identification number, or maybe the post, that's for zip codes, for those using zip codes, you could actually take that zip code also and add it to the model so that the data to train the model. Amazon offers a free 2 months usage with limits. So they allow you to use it for free to a certain extent. So there's a certain amount of a number of models that you can train, the time you can spend training them and stuff like that. So some other facts about it, you pay only for what you use. So it's a pay-as-you-go service like most other services that Amazon runs. There's no minimum, there are no minimum fees, and also there are no upfront commitments. So you can just start and use and pay for what you use. It also has it's also deeply integrated into Amazon Sagemakers. So it's good. Shola actually spoke about Sagemakers. So I think you get the idea. So you can actually take your models from Sagemaker and import them into Amazon Fraud Detector and now use them to detect fraud. it's also a regional service. So your models are region bound. So you can't use a model in certain region to actually do a service in another region. So your model has to be in a particular region. Then it's generally available in select regions. So it's not available in all regions at this moment. I think they have about 6 regions, some of which are US East, US East 1, then EU West 1, and also EU West and also Asia Pacific, Singapore. So what kind of fraud can you actually use Amazon Fraud Detector to actually mitigate? So we have new account fraud. So you can use that to screen signups. So if you have a service and some people are signing up to that service, you can actually determine if this person is a low risk sign up or a high risk sign up, and you can now, based on that information you get, you can now make some decisions. You can also use it for guest checkout fraud. So guest checkout fraud is actually when somebody, like someone like Jumia now allows you to purchase products as a guest. So you could actually, a guest can actually take a stolen credit card and now go on Jumia and now use that to buy items. So because it's a guest, the Jumia would not have enough data about that transaction and about that person that did that transaction. And they might end up having to refund the owner of the card for any liabilities and thereabouts. So you can use it for guest checkout fraud. Then also try before you buy service. So things like free tier abuse, you can use that to prevent it. And also online payment fraud, which I guess we are all familiar with. So fraud detector benefits. Fraud detector allows you to quickly build high quality fraud detection models. So you don't need to, they've done the work for you. So basically the heavy lifting has been done for you. You just step in there, import your data, select what you need, and you can quickly create a model. It takes about 40 minutes to train a model on the average. So you need to wait about 40 minutes before you can start making use of the model. Then also it allows you to stop bad actors at the door. So you don't need to be reactive. Traditionally, if you are not using machine learning, you don't know what's happening. It's probably when the fraud has been committed that you get to see the fraud. But now with machine learning can adapt. Then also you can have training cycles whereby maybe I train my model every week, or I train it every 2 weeks, so that the model is agile enough to actually detect different kinds of fraud. Online fraud expertise out of the box, that you get online fraud expertise out of the box. What this means is that Amazon is actually the guys that actually design fraud protection systems for Amazon. They are the same team that actually designed the algorithms for this service. So you don't need to pay for that expertise. You just get it free, and you can make use of the service, which is something really great. And also it empowers your fraud teams because they don't need to start. A lot of manual work will be moved aside, and they get lesser work to do, and they can now be more effective in doing the job they should be doing. So for Detector, so the target market for this is basically financial institutions. So you could actually be a bank, or maybe a cryptocurrency exchange, or maybe cryptocurrency, you're into cryptocurrency or anything related to finances. Online merchants also would benefit from this. And basically anyone needing protection against online fraud. So if you do business, or if you need to vet the people that get access to your service, or you want to be sure that you are having the right set of people to access your service, then you can make use of this service. Even as a group, we could also use that to, we can tell, okay, bad actors from the good guys. Okay, so let's do a deep dive into what used to be the traditional method of doing fraud detection versus the new method, which is using machine learning. So basically, the previous method or the traditional method of doing fraud detection was using business rules. So business rules, they would look for specific conditions or behaviors from the data. It's quite easy to, when you read them, it's quite easy to understand what they do. So for instance, we have this like an example of what a business would be like. So if IP address location is equal, it's Nigeria. So if the IP address is originating from Nigeria, and the customer address or country, so the customer says his address, he lives in UK, and the customer's phone location is Malaysia, then you have to investigate, because there's a disparity in this. So most times, if you have a Nigerian IP address, a Nigerian address for your location and also for your phone, you would tend to pass that. So it's also easy for the bad actors to actually play with this. So I could just set up a VPN that allows me to allows me to say I'm from a particular location, and also I could just use a fake address, and I could play around with this. But the beautiful thing about using machine learning is that when fraudsters make a little change to their methods, machine learning is able to detect those nuances, because the transactions or events from legitimate customers will almost be similar. So the outliers, machine learning is able to detect minimal outliers that actually are fraudulent events. Then also machine learning rules are not brittle compared to, I just told you now that you could actually play around with the business rule. If you actually have deep insights into what is being done at the back end, you could actually just play around and bypass what the rules are. So just a brief on machine learning. I know Shola has actually said a lot, so I won't really rework the wheel. But basically, we have three types of machine learning. We have the supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is when I, as a person, let's say I'm using myself as a person, train me. When I say, okay, can you teach me or train me on this? So you are giving the algorithm data. You are giving it labels. You are telling, okay, this label is for fraud. So this is fraud, this is not fraud. You are making it clear to the algorithm that differentiating what the data types are and the types of events are. So you are actually giving the algorithm what to work with. Unsupervised learning is when you just is when I say, okay, I'm self-sufficient, I can learn myself. So I don't need anybody to help me. So you give the data to the algorithm, and the algorithm looks for clusters like patterns in that data and would let you know what it sees. And reinforcement learning is when I say, okay, my life, my rules, it's and trial. In Nigeria, I think we call this trial by error. So basically, it's when you learn by mistakes. I do this, I fail, then I do something else, I succeed. So that's reinforcement learning. So the algorithm does this. You punish it by in certain ways. Then it knows what the right thing to do is, and it gets stronger by that. So just a brief on, so this is like the bigger picture for machine learning. We are actually using supervised learning. So the fraud detector is based on a supervised learning algorithm. It's using classification, which we can see fraud detection. So basically, you classify the fraud from what is legitimate transactions from fraudulent transactions. So a brief on the process. So this is the traditional method of training an algorithm. So you have your training data. I think Shola also made mention to that. So you have your training data, your test data. So you train the algorithm, and after training the algorithm, you now supply it new data. So okay, let me check if this algorithm can actually give me a prediction. So if the prediction is wrong, you retrain it. If the prediction becomes right, you can now deploy that model into production. So how does Amazon Fraud Detector work? So how does it work? The first step is actually uploading your data into S3. So the data has to be a CSV file. So you can export from your DB or data warehouse, wherever you have the data stored, and now upload to S3. Then Amazon Fraud Detector would load the data, inspect the data, and enrich it. By enriching, we mean that, say for instance, I have my IP addresses there now. Amazon Fraud Detector will use GeoIP to detect the location where that IP address is from. Then also it would select the algorithms that it would use to do that, to train the model, then do some optimizations. It will validate the performance. So when you upload your data sets, Amazon Fraud Detector will divide it into training data and test data, and validate the performance. Then finally, you can now deploy the model. Then also we have what we call the Amazon Fraud Detector detection logic. So this is basically when you combine your model with decision rules. So what this means is that when my model is ready, whenever I talk to that model, it's going to give me a model score. So based on my model score, I can define. So say for instance, ideally, normally it's between 0 and 1,000. 0 meaning that it's low risk, and 1,000 meaning that it's high risk. So if it's a sign up, so 0 is a low risk sign up, and 1,000 is a high risk sign up. So let's take 500 as our base. Our model returns 500. So we can say, okay, like anything above 500 should be considered high risk. Anything below 500 should be considered low risk. Then you make your decision based on that. I'll show us in the demo how to do that. So I'll talk more about that in the demo. Then you have the fault detector API, prediction API, which allows you to now make predictions. So basically, you now can call that API and get predictions done. So this is the automated model for building the machine learning model. So basically, Amazon, the service takes in your data. It does data validation. It enriches the data, like I said, with the likes of GeoIP and stuff like that. It pulls from other databases also. So Amazon would also use their own information to append that to yours. And so they do feature engineering, whereby they can append some other columns to your data so that you can actually have a more robust model. So they do model training and selection. Then after that, they do the performance metrics to make sure that that model can actually make predictions before you can now deploy that model. And so basically, at the end of this process, you get a customized fraud detection ML model, which is unique to your business and your use case, because they are taking your data sets and using that as a basis for creating that model. So what you have as a model will be very different from what another customer would have as a model. So using fraud detector. So basically, in order to use fraud detector, like I said, you have to upload your historical fraud data sets to Amazon S3. So you copy that into S3. You choose from a pre-built fraud detection model templates. So they have model templates already in place. As of now, they have just one, but I suspect over the years, or maybe over months and years, they would add more to that. So the model template uses your historical data as input to build a customized model, like I showed in the earlier slide. Then you can now create rules to respond to the model predictions. And finally, you can call the Amazon fraud detection API from your application. So this is the overview of building this. So building a fraud detector in AWS, this is the overview. So you first define your event, you build the model, then you build the detector. We use this as in doing the demo, so I would be able to explain that better and give us the lowdown on that. I placed some references here in case you need to do some deep dive into what it's about. So the homepage is there, the documentation. Then also you have GitHub samples. But basically, these are Jupyter notebooks so that you can use that to actually interact with the fraud detection prediction API. So it's demo time. So let me go on to the console and let's get started with the demo. Okay. So like I said, the first, okay, just a minute, please. So flags. Okay, so like I said, the first, we need to upload the data to S3. That's the first step. So upload your data into S3. So I have this data set, which I got from the Amazon website. And let me just do a brief on this. So let's see what's inside the data set. So I'll just show you the first three rows. So you can see that we have the IP address and the email address. So these are my variables. So like I said, you need a minimum of 2, but you could have a maximum of 100. So I can add like the if I'm using zip codes, I could make use of like the phone number and stuff like that. I add that to the data. Then this event timestamp and event label, they are mandatory columns. So you need to have that in your data sets. The timestamp basically speaks for itself. It's the timestamp, and the label is what allows the algorithm to be able to do the classification. So you see you have legit. Let me look for a fraudulent one so that we can differentiate the two. Okay. So you see, so here is a fraudulent event. So you see that we have basically two variables, legit and fraudulent, or fraud, sorry. Legit mean that legitimate transactions, while fraudulent is fraudulent transactions. So let's upload the data to S3. I'm going to do some, I think I should expect that most of us will be familiar with AWS CLI, but if we are not, if you need to get the CLI configured, you first need to download it. So you can do pip install AWS CLI, or you can go online to the Amazon website and download for your respective OS. Then after you do that, you can now do AWS configure. So this allows you to configure the credentials. So you have your access key, your secret key, then the default region, and at the same time, you can use your output method. So once you do that, you should be able to access this. So let's create a AWS S3. Let's make a bucket. So I'll call that AWS Nigeria user group for detector demo 1. Okay. So let's call the region. So EU. The S3 bucket has to be in the same region as. So basically, you have to make take note of that. So okay, cool. So let's now copy that. Copy this. Okay. So AWS S3 copy. Okay. So let's copy that too. Oh, sorry. Okay. I missed the S3 out of that. Okay. So that should be, once that is copied, I'll come back to that. So let's, okay, just a minute. Okay, so let me go on online. Ireland, okay. So basically this is the homepage for AWS for Detector. I'll talk more about this menu when we get along. But like I showed you, let's go back to this slide. So I told you the first step is actually define the events. So we need to define an event. So so you can actually just create an event from here. Click on create an event. Let's call this, let's say we are creating a portal for AWS user group and AWS Nigeria user group portal. Okay, portal for detector, for detection. Sorry. Okay, so let me just copy this. So basically it's just, hello? Oh. Okay, cool. So that's so we have what we call an entity. So an entity basically describes the kind of user you are creating for. So if you're an online store, you can just say an online store user. If you're a bank, if it's a bank you are doing this for, you can say bank customer as the entity. So it's just it's the entity you are creating this for. So let's say user group, just a user AWS user group. Okay, so that's just a user. We now create that. Okay, so that's our entity. So just a normal user in our group. Then for the variables like I showed you earlier, you have the IP address, the email address. So you can also define more variables. If you have, you can divide variables on the portal and then use them later. But let's use that from our training data set. So I'll just upload the training data set and we'll use that data. So let me copy our S3 buckets. So this is the location where your file is in S3. That's what you need. So copy that. Then you need to create an IAM role to be able to, so that for detector can have access to that S3 data, the files in S3. You can choose to create an IAM role using for detector, or if you don't have the credentials to do that, you can talk to your admin and let them give you access. So basically, you need the Amazon for detector data access policy to be able to do this. So I have some rules already. So let me just make use of those. So at this stage, we are just trying to understand what kind of data we have. So we are Amazon for detector will look at the data and look at our columns, and we can make decisions on which variables we want to add into that the model. It's the data for the model to be trained. So you can choose to remove. Let's say I have like 20 different rules. I can choose to remove certain variables that I don't want to be part of this. Then I leave but for this, since it's just to our IP address and email, I'll leave those so we can make use of that. Then labels. So like I showed us earlier, labels are, so that, let me go back to that. So just a minute. Okay, so these are your labels. So legitimate, for legitimate transactions are legit, and fraudulent ones are fraud. You could also say maybe yes or no. So maybe in your data sets, you mean yes means that these transactions are valid ones. No means that they are fraudulent ones. So you need to create a label for that. I already have fraud legit. If it's if you need to create a new label, say for instance, let's say yes now. So it's as easy as just say type in yes and create the label. You understand? So this gets selected, but I would use the ones for fraud and legit. If you miss this step, your model training will fail. So it's very important that you define it properly. I don't need to really add tags. I can leave the tags. So we create an event type. Okay, so once I've done that, I've created my events. So from this now, you see the define events is done. I move on to build the model. So that's the next step. We go. So I basically talked about events here. Entities I talked about already. Then let's click on models. So now we can create a model for that particular event. So we can also, you see, we can import from Sagemaker, but I'll talk about Sagemaker a bit down the line. So the model name, let me use the same. Okay, AWS Nigeria User Group Portal. So model. Sorry, underscore Nigeria user portal. Okay, model. Okay, so description is optional. We can skip that if we want to. So like I said, so AWS allows you to actually use certain models. The only one they have right now is the online fraud insight model. So I expect that over the maybe coming weeks and months, they would start adding more. Let's say for something like spam detection model, you know, so that you can actually do spam detection and stuff like that. But for now, it's just the online fraud insights model. And this allows you to do new account fraud detection, online payment fraud detection, and also fake reviews abuse detection. So now we select our event type, which we created earlier. So the portal, I'll select the one that has portal. Okay. So once I select that, I can go below. So now I need to upload my data into for the service to now make use of. Let me select my IAM role, which is the same the same one you would have created earlier. So let's copy the S3 bucket location again. Okay. So the location and the file itself is what you need. So this is where my S3, my data for S3. Model tags are optional. Then we click next. Okay. So now it tells you, okay, which variables do you want to add to this training? So at this point, I can also remove models. I can uncheck or leave them. Since I have two, I need to just use the two, which is the base amounts or the least amount you can actually make use of. So now it's asking for my fraud labels. So I have the fraud label is fraud. So in your case, if you are saying fraud is like, let's say no, it's yes, it's fraud. You now select yes. If it's no, you select no. My legitimate labels. So these are for legitimate events or transactions. I click legit. Okay. Then I click next. So at this stage, I'm ready to start training this model. So I can review everything I've done and see if I need to make changes. Then I can create and train the model. So like I said earlier, it will take about 40 minutes to actually train this model. So I would go into another model which I'd actually trained earlier. So you see where we stopped. This is the model page. Okay. So let me go to let me look for a model that we've trained earlier. So I have this high risk sign up model which I have already. So so basically, you can see that it's version 1.0. So AWS does the versioning for you, and also it does metrics. It does performance metrics. So like I told you, it will test. It splits the data into training and testing data and tests the algorithm to be sure that it's robust enough to actually make predictions. Performance, the area under curve, that's the AUC. Normally ranges between it ranges from 0 to 1. An AUC of 0.5 means that model cannot really make predictions. You can't rely on it for predictions. And an AUC of 1 means that it's a very reliable model. But 0.96 is also is a very, very good score for that. So it also makes sense to use that. Okay. So let's talk a bit more about the models before we now create the next. We now go to the next step. So basically, the model, you can see the version details. So it tells you what version you have and the status of your model. This is where I want to focus on now, the model performance. So like I said earlier, an AUC of 0.96 is really good. 1 means that 1 is the highest number you can get for the area under the curve. I'll use this table option to explain how to now. So basically, Amazon now lets you know it gives you some insight into what that model is actually doing, and now you can now make decisions based on that. Okay, like when should I decide what to use for the model? Like I said, we have what we call a model threshold. So that is the score. If I do a prediction, let's say I have a user an email address and an IP address, and I want to make a prediction against that. So I want to know whether this person is a high risk sign up or a low risk sign up. It will give me a model score. So that the model threshold is the model score that you get. So let's take something like 855 now, for instance. Let's say I want to adopt a model score of 855. So what this means that anything below 855, I will consider it as a low risk sign up. And anything above 855, I'll consider as a high risk sign up. So the false positive rate of 3% means that when the model does the classification, 3% of the data that is classified as fraud would end up being legitimate transactions. So that's a false positive. So it means that 3% of the events that you have classified as fraudulent would actually be legitimate if you, in the end. A true positive rate means that, so we are still on this model threshold of 855. A true positive rate means that out of my transactions that are labeled as valid, 79% of them would actually be valid. So it means that out of all those that are labeled to be valid, 79% of them will be labeled as valid. Then the precision now says that, so basic precision is about anything above 855. If I send it to the fraud, so let's say for instance, I'm sending that to my fraud team. Anything above 855, when my fraud team looks at it, 59% of those transactions would end up being fraud. So that's what the precision actually talks about. You can read more about it, and I also put some links to actually give more insights into that. Okay, so let's go to the next step, which is let's build our detector. So that's still about the model. So let's build a detector now. So, okay. So in building the detector, I'll now talk about what the detector does. So the model, I've talked about the model. So let's create a detector. Okay. So let's AWS user group in Nigeria. Okay, so let's say portal also, so that we can differentiate it, portal. Okay, let me call demo. Okay, so the event type has to be the one you created at the start. So you create portal, so you select your portal. But because, you know, I'm still training the model, so the model is still in training. So I need to use one that is actually ready. So let me select the IRIS signups for this. So you go to, I click next. Okay, so so basically I need to add, so that detector now, I need to add a model to my detector. So basically what my detector is doing is, the model will give the detector a score. So my detector is what makes the decision. So based on the score, so like we chose 855 earlier. So if I'm using a model score of 855, so I tell the detector, if you find out that this person has a score of 855, which is above 855, sorry, send that information, maybe send the person, make sure the person goes through SMS validation, or maybe make the person go through phone validation. So meaning that the person will get an SMS on his phone and has to go to the website and enter the code that is given in the SMS. Or you could, depending on your nature, you could actually do some more KYC. So probably you have to call the person, depending on the kind of service you do. If it's less than 855, then you can now, you can just tell you can just allow the event to go through. So that could be a registration, allow the registration to work and give the feedback that you successfully registered. So let's add a model. You can add your detector model, the ones you created earlier, or you can add SageMaker endpoints. So Shola had actually talked about this. So I think we should understand what those are. So let me add, so this is my model. So I click on that. Then I select this. Then I add the model. One thing I failed to say earlier is that your model has to be in, what's it called now? It has to be deployed. I'll show you how to deploy the model. But your model has to be deployed before you can select it. So once I select the model, I click on next. Then let's now do, so I'm going to do 2 rules. So I'm going to use a model score of 500. Then I'll tell the logic, anything below 500, consider it to be low risk. So allow it to pass and allow the registration to happen. But anything above 500, do a due diligence. So probably send an SMS to the person, do an SMS validation. before the person can now move to the next stage. Okay, so AWS, okay, AWS user group. Okay, portal. So we call this our low risk rule. Low risk sign up. Let's say sign up. Low risk sign up. Okay. So so here we have Amazon has an expression language, which Amazon for Detector expression language, which is so it's basically like coding, but it's quite simple. There's a reference guide below here. So like I told us, we are going to use a model score of 500. So let's see what we'll do now. So you type $, it will give you all the variables. So these are all the variables that we selected at the onset when we were creating, we were trying to train the model. So my high risk sign up model insight score is what I'll select. That is the one for my model. So I would say that if that's the score that the model gives me is, so this is low risk. So meaning that if it's less than 500, then it should allow the transaction to go through. You can also do an and, maybe and email. If you want to say email is, so you could also do some other logic to that, but I'll just keep it simple. So let's do that. So we keep this simple. Then what the outcome is now what should happen. So if you are doing this on a website, so the outcome is, okay, if it's a low risk sign up, the outcome can be that, okay, I'll allow the registration to happen. So that means you just give the person a feedback form that, okay, your registration was successful. If it's high risk, then you can do like SMS validation, phone validation. So I already have some here, but let me create a new one so that we can understand. So I'll say SMS, okay, it's a low risk. So I'll say good registration. Let's use that, good. So let's just use that if that's meaningful enough. So good registration. So meaning that the registration is successful or is good. So once that your software detects that or your web application detects that, it can now do the needful. So let's add the rule. So that's the first rule. So that's for our low risk. So we would add another rule, which is for the high risk group. So let me copy this to make things easier. Okay. So sorry. Okay. No. Oh, sorry. I just messed that up. Oh, but, sorry, I'm very sorry about that. I think I just messed this up. Detector. Okay. Oh, I have to start up again. I just messed up that. Sorry, I'm very sorry. So, okay, at least we get to understand it better. So, Iris, I'm using this. Then, okay. Portal, sorry. Okay, so next. So, let me add the model. Sorry, I just lost my way now. Okay, sorry. Which one? Okay, this was the one I did before. Okay. Right? This was the rule. So the detector. Okay, let me start again. Sorry, I just messed up what I was doing. So let me create the detector. So AWS portal detector. I hope I've not confused us a bit. So I'm using this event type. I'm using the one we've created. You know, our model is still in training. That's why we're having to use something else. So let me add the model. So high risk. So that's the model. It's already deployed. So let me add that to it. I'm very sorry about the mix-up. So okay. So we say if the high risk model is high risk is less than 500. If the model gives less than 500, then do a good registration. Then add the rule. Okay. So let me add another rule. So this rule now should be for create a rule. Sorry, this way. Okay. So this rule now should be for the high risk group. So if it's high risk, okay. So meaning that this is greater than 500 right now. So if this is greater than 500, then our outcome now, we now say, okay, let's say SMS validation. Let's create a new outcome. Let's call that SMS validation. So the person has to validate that the are the owner of the phone. Validation. Okay, so save the outcome. Okay. So high risk. Okay, so let's add the rule. Okay, good. So we said we have two rules now. So we have the low risk rule and the high risk rule. So you can do more than 2. It doesn't have to be 2, but you can. So probably you can set between 0 and 1,000. You can say okay, 0 to 300, then 300 and to 800, then 800 upwards. So you can actually play around it if you depend on how you want it to be. So this is where the rule execution comes into play now. So which rule should come up first before the other? So ideally, it will make sense for the low risk one to come first. So if the person is low risk, we don't worry about that. If the person is high risk, then we do SMS validation. So let me click on next. We can review everything we are doing and see if it's good. Then I can now create the detector. Okay, cool. So once that detector is created, if you go to your detector page, so you see all our detectors are listed here. So this is the one we just created now, the AWS user group portal. So you can, AWS gives you a way to actually test this. So you can click on the detector, that's the version number. Then, okay, let's just do some predictions now. Let's try to play around and get. So let me do fake. Sam, I hope I still have enough time to work with this.
Yeah, you do. Go ahead.
Okay, thank you. Okay, so let's just call this guy Mike, fake Mike at okay, example.org. Okay. Sorry. Okay. So from what I noticed, maybe this is a bit biased also, but some countries also, depending on the country you come from, I notice it tends to classify sometimes as high risk and low risk. So now I have some Nigeria IP addresses here. So let's take a like this global.com IP. Let's just take that and let's see what comes up. So I'm just using a any email address. It could actually be, you could also, if you are testing, you could use your own to see how you rank. This will be generated by default. So let me run the test. So you see that it gives me a score of 989, which means that it's a high risk sign up. So it's you might call this a bit biased, but like I notice countries like Nigeria, Iran, Afghanistan, they tend to come up with high risk or into the high risk range. Let me do something else now. Let's see our data now. Let's look for data that we can use from this so that we can verify that this is actually, so this is saying it's legit. So let me copy this email address. So let's see if actually it will work well. So it's saying it's legit. So ideally this person should be good to go. Let's copy the email address too, the IP address, sorry. Okay, so let's run a test. So is that the score is 158. So it's actually, the person is considered a low risk sign up. So we can allow the person to actually just go through with their registration. Let's do this to validate that we can actually. Okay. So the IP address again. Okay. So let's run the test. Okay. You see that it's actually classifying this as fraudulent, high risk, because it's already in our data. Let me do something else now. Let me look for a country that's normally is considered, so let me use Denmark. So let's look for an IP in Denmark. Okay, so let's just use this IP address. Okay. Then let me call this person Fake Dane. Okay, cool. So let's see if, okay, so it's classifying this as high risk. So you see that it's actually making the detections. So ideally, I was expecting this to be low risk, but you can't really tell sometimes. But based on our data, it's you see that it's working the way it should. Okay, so you can actually, they have APIs for you to actually make use of. So you have the normal SDK, the Python SDK, you have the Node and Java SDKs, which I'll use that. I'll show you how to do that right now. But before I move, let me just talk about deploying your model. So if you have a model in production, so if you have a model that you want to deploy, you can just click on it and let me see which model I've not deployed yet. So just a minute, please. Okay, I think this one is not yet deployed. So if I click on it, okay. So click on the version. Okay, so you can, once you want to deploy, once you have a model and you are sure that you like what it does, you can deploy the model into production and now start using it as, I'll show you how to make use of the production from your APIs, which is what we'll do next. So I think I've covered all this. So the detectors, the models, and all events, then also what the outcomes are. I've covered that. Okay, thank you. So next, let's play around with the detection APIs now. Okay, so let's go into the API. I actually wanted to do a Flags application so that you could actually see it as a web app, but like I told you, it was just this week that this got released. So I couldn't finish up everything I was doing. So I'll just show you what the Python one has. So I have two methods. There's the get detector method. So basically what the get detector method does is that it would get all the detectors you have on your site. That's in your region, depending on which region you are actually working with. Then also you can now use a get prediction. So it uses the standard Boto3 library. And I'm also using JSON to actually pass some of the data. So here I'm using the client, the for detector client, and basically I'm just telling it, okay, get detectors. So if I run this, it should list all the detectors that I have listed on the site. So let me run that now. Okay, so this is not neat. Let me use JQ to pass it. So let's just pass that with JQ. So it will give you, so basically it returns JSON. So you have to be familiar with JSON if you are going to be using this. So you see what, you see the detectors now. So we have the one we created, the portal one. So this is another detector that I created earlier. So you have all this, so it lists all the detectors that you've actually created on the site. Then let me now run one for, let me show you the one for, I can hand this code over to Sam so that you can actually share it, so you can play around with it. So so basically, same, we are using Boto3, JSON, then also, but this method is actually the get event prediction method. So basically what we are doing the same thing we did here. We are doing the same thing we did here where I was testing with the IP addresses. So I have this this username, the email address, and also this IP address. So basically what you need to do is just change this email address, change this IP address, and now run that prediction. So let's run this now. So Python, okay, so get prediction. So it would, okay. So it's giving me a prediction. Let me run it through JQ so that I can get decent outputs for you to see. Okay, so so basically this is so basically your APIs would interact in this method. So you have your web application, it's interacting with the API and it's getting feedback. So based on the model score, you can decide what you need to do. You understand? So the model score now, we can see that the score. So under this this score is 989 for this. This is a high risk sign up, and it's not a, so basically once it detects this, the outcome is send SMS. So you can tell the person, okay, do SMS validation before you move to the next stage. Okay, so let's try something. Let's try another. Let's try another one. And sorry, let me choose out of those I did earlier. Just a minute, please. Okay, so this is a legit one, so I should expect that this would turn out legit, and the score will be pretty low. Okay, so let's now. Okay. Just a minute. Okay, let's. Okay, so. Okay, so I'm just swapping that those IPs. Okay. Okay, so the email address first, then the IP address. Okay, I think that's good. So we can run a prediction with this now. So I'm expecting that it will be a low risk because it's, okay, cool. So you see, it's saying the score is 1. This is the first time I'm getting something under 100, which is funny. So the score is 1. So it's a very low risk sign up. And the outcome is allow access. So we see that, you see how this plays out. So basically you can use this for your website. You can use it for anything. If you want to, if you are doing something and you need to validate that an IP address or a certain entities, it will be safe to do business with or safe to work with, you can use that to validate. You can do complex stuff with this also. Then there's also a Jupyter notebook. I don't know if I have the time to do that. Like Sam, how many minutes do we have left?
I would say about 5 more minutes.
5 minutes. Okay, let's see if we can start up a Jupyter notebook. And so I'll just show you how to use a Jupyter notebook to do that. So let's go to SageMaker. I hope the FA Cup guys will not get angry with me. Okay. So this is a notebook. Shola already talked about Jupyter notebooks. So I'll just create one without really talking much about it. So if you want to create one, we just create this. Let me see, AWS Nigeria user group. Okay, so let me use a T2. Then, okay, I would, okay. Enable, allow root access, encryption. I don't need encryption, network, okay. Default VPC, subnets, okay. Okay, so let's use the default, okay. So it should enable internet access directly, so I don't need to worry about. So there's this, I put this here. So this is the 4 detection samples. It's a GitHub GitHub repo where you can find the, so you have Jupyter notebooks here, and you can use them for simulating this. So let me copy that too. So clone a public Git repository. So let's add that to this. Okay. Okay. So I think I'm good to go. Sorry, the name. Can include iPhone. Okay. Okay, cool. So it should take about some few minutes. I think we can do Q&A. Then I would just do the, is that good?
Yeah, let's do that.
Okay.
Thank you very much.
Thank you very much. Okay, cool.
So yeah, we will open the floor to Q&A now. But before we do that, Akim, is it okay to share the phone?
Yeah, I think we can share it. Yeah.
All right,
do you have the link? You can paste it in
yes. All right, perfect. So I'm going to paste a link in the chat to everyone right now. It's just a couple questions, and we're going to, the first 2 people that answer the questions, we're going to give them the free AWS credit, $25. So I'm going to paste that now. But, yeah, and the floor is open for any questions for either Kunle or Shola. So please, if you guys have any questions, now is the time. I actually have one question for, let me go actually before, I have one question for Shola. Shola, if you're still with us. My question is for somebody that has no exposure to data science or anything, or data engineering or anything like that. What would you say is the use case that I would want to use Amazon SageMaker Studio? Say a beginner, somebody that doesn't have experience with it.
Okay, I'm with you.
Thank you.
Can you hear me?
Yes, we can.
Okay. So the approach I would suggest for a beginner is to explore the AutoML and Autopilot. And whenever if you go through the AWS SageMaker, there's a place where there are example notebooks, and what you would basically see there are notebooks already rewritten for use cases, the common use cases that we have. So take, for example, I work for a data marketing company. So we do marketing using data. And very first time I used SageMaker, there was actually an example that was for people that do marketing. So take, for example, people that would either purchase or not purchase based on some data points. So that was a perfect use case for me to try and to start. So what you have to do is you have to explore, you have to check the examples, you have to look at what they have for a start and think of what is most appropriate for your use case. So when you decide what is most appropriate, the next is to play around with the data sets, upload to S3, try to run the cells, and just go from beginning to the end. So that's for this.
What type of use cases are we talking about? Since you mentioned like use cases, so how do I know I need to use like Sagemakers?
Okay, so it depends on your on the field or on the vertical you're playing. So if it's for example, if you work or if you're looking to do stuff relating to image recognition, let's say you want to do a facial recognition of something, maybe cat and dog, the popular one that people do. So you typically find notebooks that would fit into that category. So all you have to do is you have to check to start with to see if there's anything that is best suited for your use case. So the list is there are a lot of examples that they have. I can't remember from the top of my head. I know there's the marketing bit, there's image recognition, there's fraud detection, like like we just talked about now. So you need to look through what they have and see if it would work. That's on one side. On the other side, you could also choose to build yourself. One mistake people make is they try to start with complex stuff. So you can, if you take a course on Python or data science and you know the most basic things around how to even build a model, you can try a simple scikit-learn model and a simple evaluation metric. The most popular one that starters use is accuracy before people now progress to other evaluation metrics. So you can start with the popular ones and you just try to play around. In the event that you don't find a use case that would work perfectly for you. So that's the way I would advise that newbies should approach it.
Thank you for that.
Yeah.
I see Kola has his hand up. So Kola, do you want to go?
Yeah, thank you very much. I really
Kola, I think your network is not stable. We cannot hear you.
really appreciate it. Actually, I did not. Can you hear me, please?
Yes,
Hello?
now we can hear you better. Now it's better.
Hello?
Yes, now it's better. Go ahead.
Okay. Better. Yeah, presentation. And then my question, second presenter, to quickly for that project, for that fraud detector, to shed more light on the algorithm.
Okay. Which of the algorithms?
For the fraud, for the detector.
Okay. Is it the online fraud sites or which one are you talking about?
I'm talking about the detector of that,
Okay, the Python one.
Of the project, yeah.
Oh, okay.
I'm just the fraud detector. Actually, the project is all about the fraud detector, and you build your model and you load your data set, and there should be an algorithm. I just need more you to shed more light the kind of algorithm that you use that can detect that this one is fraud or not.
Oh, okay. Yeah, like I said, AWS actually supplies the algorithm. So that's the online fraud sites one I showed earlier. So basically AWS, so you are not doing much. You are only providing your data and deciding, okay, these are the variables I need the model to use to decide to be making predictions. You understand? So you are not really, so AWS is supplying the algorithm itself. So they have one they call the online fraud insights model. So that is what AWS uses. They take your data, they append their own data and some other things to it to now train a model that you can now make use of. So you're not really doing much. It's more like it's a managed service, if you get what I mean. Or like if you are using SageMaker now, SageMaker, you are the one doing you are doing the work yourself. So you build the model, you train the model, then you can now deploy it. But AWS is just saying,
so
okay, bring your data. Yeah, go ahead, please.
So I can't know maybe it's a linear regression or logic regression or decision
it's
tree
classification.
or neural
I'd
network.
actually talked about that. So they are using classification, but I'm not sure but so it's basically the classification algorithm. So I don't know whether it's linear regression or I'm not actually sure if which of it is actually, because they didn't say. But I just know it's a classification. It's supervised learning.
Okay, thank you.
Okay, you're welcome. Okay, so
Sam, can I
just quickly finish this? And it's just I think 2 minutes more and I'll be done.
Okay, yeah, please go ahead.
Okay, cool.
So this is your hand is up, so I'll come back to you right after.
Okay, cool. So this is the notebook I started. So once you load that notebook, you have 2 notebooks there. There's one that has end-to-end. So end-to-end allows you to do everything from start to finish. So like we created the events, we created models. So you can use the end-to-end to actually do that. While the get event prediction API just allows you to get predictions. So that means you must have deployed your model and your model is in production. Not that it's production, but it's deployed. Then you can now start using it. So let me just do a sample. I have this code here, which I will share with us. So there are actually 3 steps to this. So you have to import the Boto 3. So click on import Boto 3. Okay, then we click run. So the next step is now to let's associate the clients to that. So which is the 4 detector client. So last but not the least is now to run the, so you have to change the IP, the email and also the IP address. So if you could also automate this if you are using the Python script. So the choice is yours. So let's do this. So once I run this, it should give me the prediction. End of, oh, sorry, okay. Okay, sorry, let me fix this. I think there's something wrong with this. Okay. And the funny thing is I tested this before, so okay, yeah, this is the you know, the method was not enclosed. I think that was why. So this is, yeah, cool.
Yeah.
So once you run that, it should give you the so the model type. You see the online fraud insights. That's what AWS that's where the algorithm, what kind of algorithm AWS is using to actually train this. But what we are interested in is actually the score. So the score is 989 for this. So the score is 989, and the outcome is send SMS. So this means that this person is a high risk sign up. So we have to let him validate his phone number by sending an SMS to him, and he would now validate that before we can allow him to go through. So these are the various methods you can actually play around with the API. I think it's not as rich as, although they've tried, but it's not like the other ones are established already. But I think over time they would keep working on it since it's a new service. Okay, thank you very much. Okay, over to you, Sam.
Thank you.
Thanks, Sam. So, someone wanted to ask question, I think, Doing.
Yes, Doing, over to you, please ask your question.
Okay, good evening.
Good evening.
My question goes to Shola. I'm very new to AWS, and I could see from your slide that you uploaded your training data to S3. Then from S3, you took it to Sagemaker to train. Then from Sagemaker, I saw you had what is Athena, Amazon Athena. So I don't know what that was. But I'm just so new in it, so can you shed more light on that?
Okay, so can you hear me?
Yeah, I can hear you.
All right, so Athena is another service on AWS. So it's SQL based. So what you basically do, people refer to Athena like a data lake, meaning where you have an aggregation of your data from different sources, and it's all in that platform or that service, as the case might be. So what you do with Athena is you write SQL queries and you're able to visualize your data. You're able to see what is happening. The reason why I included Athena in what I'm doing is, so take for example, I do a machine learning or I do a training. I score the users based on, let me use fraud for example, whether the user will be fraudulent or not. And I score each user, or I tag users, the user as either a fraud or legit. So what happens is, for you to work with that data, two things would happen. Either you deploy the model as an endpoint, or you can have like a batch prediction. So
Okay.
if you deploy it as an endpoint, then it can be consumed by an API. And when people call the API, just like we are saying now, when people call the API, you can get the result on the fly. On the other end, when you want to do a batch prediction, you don't necessarily want to integrate it into an API, or you don't want to have an API. You basically want to take, for example, be able to store the outcome at rest. And when there's a need to use it, to go and check writing SQL queries, or you can even download the CSV, whatever it is you will do. The end goal is to help your business processes, make intelligent decisions. So in a nutshell, Athena is just a place where you can write SQL queries, with the different databases what you have. You can join and merge data set on Athena, and people see it as a data lake, basically.
Okay. Okay.
Yeah.
Thank you.
Okay, so there's another question for me. So let me just go on Wale. So he's asking the difference or differences between TensorFlow and SageMaker. So to start with, there are two different things. TensorFlow is a framework that allows you to build deep learning models. So the popular deep learning use case that you see out there is, for example, classification of images, like cat and dog. So what happens is you want your computer to tell you if this is a cat or a dog. So for you to get to that point where the classification happens, you need a very strong framework that is backed by some crazy architecture, neural networks, a lot of hidden layers, depending on what you build. So TensorFlow is a framework that helps you do something like that. For SageMaker is a service on AWS where you can build, where you can use a TensorFlow to build, where you can use something else to build. And at the end of it all, you solve problems based on your use cases. So there are two different things. Let me just add a little more to it. So for you to use TensorFlow on SageMaker, you can go into directions. Either you use some of their pre-built models. So they have pre-built models for TensorFlow. And the reason is because there are a lot of dependencies for you to get TensorFlow up and running. So all that has been taken care of. So when you use their pre-built model, if it fits your use case, all you have to do is just provide your data set and you're good to go. But in the event that you want to build your own from the scratch, so that's where you get to use Docker, containerization and the likes. So you basically want to ship what you have locally to the AWS environment so you can have the same results. So I don't know if that answers your question, Wale.
Wale, does that answer your question?
Okay, sure. Sure.
Okay, perfect. Thank you.
Let me say this last thing. So I like that we just did this fraud detection, and we didn't have a lot of visibility into what was happening under the hood. And it ties back to what I was discussing about SageMaker Studio and AutoML. So under the hood, you will see that there are a lot of things going on that you don't know. It's a classification problem. Someone was asking, what choice of model was it? Was it a logistic regression? Was it XGBoost? And it goes on. So typically you would not know, but with a service like SageMaker Studio, what happens is by the time they extend the functionalities, you will get to see that you can even have the notebook that was used to train this stuff Kunle just showed us. So what you say is, if it's a logistic regression, you have visibility into it. So it's like a white box approach. You know what kind of model was used, you know the hyperparameter tuning, and whatever it is that was used to achieve this end goal of classifying as either fraud or legit, and it goes on. So by the time they add more functionalities, I'm sure we'll begin to see a lot of all these things, and it makes life generally easier for everyone. Yeah, so that's it for me.
Sure. Thank you. I actually have one question for Kunle. Do you foresee that the outcomes, or maybe I'm not sure if I saw that or not, but can you connect that with, say, AWS Lambda?
Yeah, you should be able to.
Okay. Perfect.
You should be able to, yeah. But not, okay, are you asking from the portal itself, right?
On the AWS console, yes.
No, I didn't. There was nothing mentioned about that.
Right, but you can integrate it within your application.
Yeah, but I think you can, you can build an application to integrate it or connect it together. So maybe you are using a state machine. So the state machine looks out for the JSON, and from there, so now triggers the Lambda job.
Yeah.
I have a question. This is Akeem. So I have a question for either Adeshola or Adekunle. So the question is, can AWS fraud detector works on a live data? Meaning like online transaction, can, rather than you offloading your historical data into a CVS, can you have it work live as somebody's buying something on your e-commerce, and at the same time, fraud detectors is running on the background and actually sending out alerts?
Yes, it actually can. So I think that's your question, right?
Yeah. That's
okay,
my question.
So it actually can, but the thing is, you need data to actually train the model. So, but once the model is in production, you can use it on the fly. So like what I was doing on the CLI, it's just that I couldn't finish building the Flask application. So I wanted to show you like as a web app. So basically your user types in the use case we used. The user puts the email address and you can detect the IP address. So before you go to the next stage, you send the data to AWS for detector. So you give it the username, the email address and the IP address, and it does the detection, gives you a model score. So based on the model score, you can use that to make decisions on what next to do for the customer. You understand?
I see.
So you can actually use it on the fly. Yeah.
I see. So you would train the machine, and then based on what you train it, you can actually use that to predict what's going to happen in the future based on the transaction,
exactly.
Right?
Exactly. So once you've trained, you can now use it.
Very good. Very good. Thanks. Good job, guys.
Yep. Any other questions? Okay. All right. Thank you very much, Kunle. Thank you very much, Shola. This was really awesome presentation from you guys. Thank you for the time you must have spent to do all of that.
Thank you too.
No problem. So quick announcements. The raffle winners. We had some responses, but there were only two people actually got both answers correct. Martins Young and Abiola Oshodi. So we are going to reach out to you. Thank you for providing your email address. We will send you the coupons. So congrats guys. And secondly, we, as a community, AWS Nigeria user group, we are always looking for volunteers. So if you want to volunteer to do a presentation, if there's something you're working on, if there's something that you have worked on that you think is super cool and you would like to share with the group, please feel free to reach out. Feel free to message any of us, Akeem and I and Wale, and or even just notify everybody in the WhatsApp group. And we are always welcoming people to help. It's a large group and there's a lot to do. So please let's all work together and make do more exciting stuff like this. And yeah, if you also have ideas, if you don't have the time to volunteer and you just have ideas, again, please reach out to us. We are very open-minded. We are very flexible. And reach out to us with your ideas, and we'll definitely see what we can do about it. And that will be the end of today's session. Thank you very much for everybody. Thank you very much for coming. This was amazing. Thank you to the presenters. I hope everybody has a great weekend.
You too. Thank you, guys.
Take care, everyone.
Thanks, guys. Yeah.
Bye.
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 Thank you, guys.